Hello everyone, I am Dr. Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. In this video, we are going to discuss a number of problems using sliding window approach. In our earlier video also, we discussed sliding window approach. Now some more problems we are going to discuss on this particular approach. So let us start. What is sliding window approach and how to solve problems using sliding window. Now, sliding window is a very popular competitive programming technique where the input is normally in the form of a list or a string, and we need to find out the sublist or subarray or substrings out of it. So where we will find it out the particular answer for a particular problem by sliding by taking a window size of by taking a particular window size and sliding over the array or list. Okay. Now, how will you do this sliding window approach? Let us understand through this problem. So, the first problem is find all anagrams in a string. Now, let us go through the problem statement and understand it first. Now, given two strings S and P, return an array of all the start indices of P's anagram in S. You may return the answer in any order. That means you have been given two strings, one is S and one is P. You have to check the P's anagrams in S. If it is found, then you have to return their starting indices and you have to store it in a list and you have to return it. Now, what is an anagram normally? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using the original letters exactly once. That means, suppose if I have my P is equal to ABC, which is a string, then what can be the anagrams? So, the anagrams are nothing but it can be BAC. So, same letters you have to use, you have to just rearrange. It may be a CBA, okay? It may be BCA, okay? It may be CAB. These are called the anagrams of my original P. So, if these kind of anagrams are available in S, then we have to return the starting index of it. Means from where it starts, starting index in S, we have to find it out for those anagrams and you have to return. Now let us understand the first test case. Here P is ABC and S is CBA, a big string is given. Now ABC, the anagram, if you will see, if you will take the sliding window, it is CBA. Okay. Now here, what is length of P? Length of P is 3. So, we'll take window size of 3. Okay. So, 3 characters I will slide. So, if I'll take my first slide as CBA, CBA is anagram of ABC. Okay. Then, what is the starting index of this anagram? It starts from index number 0. So, we will store it into a list that the starting index of this anagram is 0. We will store it. Okay. Next, you slide over it. Now, next slide is my BAE. BAE is not anagram of ABC. Okay. So, don't do anything. Next slide is AEB. It is also not an anagram. Next slide is EBA. It is also not an anagram. Next slide is BAB. Not an anagram. Next slide is ABA. Not an anagram. Next slide is BAC. It is an anagram. So, BAC is an anagram. So, what is the index of this B? It is at 6th index. 0, 1, 2, 3, 4, 5, 6. So, it is at 6th index. So, BAC is an anagram of ABC. So, its starting index is 6. So, we will store the starting index into or append it to a list. Then, the last one is ACD, which is not an anagram. So, we have taken the window size of 3, which is nothing but the length of P, and we have slided over the original string S. And for each window size, we will check that that particular window size is containing a substring. That substring is an anagram of the original string P. If it is an anagram, then from where the substring starts, we have to note down that index. Okay. I hope the question is understood. So let us start with the second year test case. So here P is nothing but AB. So our window size is 2. Okay. So my window size is 2. Now this AB, I have to first take the first substring, which is AB. Okay, it is available. So starting index is 0. Next, I'll check BA. BA is also an anagram. So its starting index is 1. Similarly, if I'll take the third slide, then the third starting index is 2. That is also AB. So here, whatever the substring you take, every substring is every substring in this string S is an anagram of P. Every substring of S is an anagram of P. Therefore, their starting indices are 0, 1 and 2. I hope the question is understood. Now, how to solve this problem and write the code in Python? Let us see and understand. So, let us take ABAB. That is second test case for understanding the answer, and P is AB. Now, what is my S? S is ABAB and my P is AB. Okay. Now, so S and P are given as parameters to the function. And what you have to return? You have to return a list of integers. So, initially, I'll find it out what is length of P. So, K is length of P, which is nothing but 2. Okay. Now, I'm making a dictionary that is called p value. So what is that p value? P value, we are using the built-in counter method. So it will count of the characters and it will form a dictionary. Okay. So how many characters are there in P? It is A. A is there how many times? It is there one time. And B is there one time. Okay. This kind of dictionary you have prepared, which is nothing but this. Right. Now, for storing the result, we are taking a resultant list which is initially empty. Right. Now, we have to find out the substrings first. So, from where to where? From the length of S to K minus K plus 1. So, what is length of substring? Length of S is 4. So, my length of S is 4. My K is nothing but my window size. K value is 2. So, it is 4 minus 2 plus 1. Okay. So, it is 3 times. So, I will run from 0, 1, 2. 3 times it is going to run. So, 3 substrings we are going to find it out. Now, so what we are going to do first slice, how we are doing? We are doing from S of I to I plus K. Okay. What is the value of I? First slice is S of I is equal to 0. 2, 0 plus K is 2. 0 to 2. So, my string is ABAB. Okay. It is at index number 0, 1, 2, 3. So 0 to 2 means my first substring is AB. Okay. This is my first substring AB. We got it. Then we are applying the substring to the counter method. That means we will convert into dictionary. So if you will convert this into dictionary, it will look like A is present one time and B is present one time. So this is the output of counter method. If it is same as the p value, is it same as the p value? Yes, it is same as the p value. If it is same, then result dot append. Result, what you have to append? We have to append the I value. What is the value of I? 0. So 0 will be appended in the beginning. Now, next time I value becomes 1. So S of it is 1 colon 3. 1 colon 3 is nothing but it is BA. So it is nothing but the substring BA. Okay. Now, if you will convert into the counter method, so B is there one time and A is there one time. Fine. So it is BA. Now, what do you have to do? This is same as the P value. Is it same as P value? Yes. Okay. If it is yes, then what you have to append? We have to append to the result the starting index. That is I value. I value is 1. Right? Okay. Next time. SE is equal to, SE is from 2 to 4. S is from 2 to 4. So the third substring is again AB. If you convert into dictionary, A is one time and B is one time. So is it same as P value? Yes, it is same as P value. If it is same, then you append the index. Starting index is 2, you append to result. So finally, this is my output. Okay. So final return the result. This is my output. So in this way, we are finding all anagrams in the string and we are storing its starting indices. I hope this question is understood. What is sliding window approach and how to find it out, anagrams, or how to check the anagrams of a particular string P in S. Now let us move on to the next question. Now the next question is maximum average subarray 1. Now what is the problem statement? Let us first read it and understand it. You are given an integer array nums consisting of n elements and an integer k. Okay, so that means you have been given a nums array and an integer value k. So normally in any sliding window problem, first of all the input should be in list or an array or it should be a string, and there should be window size also, k should be given. So here both are given. Now find a contiguous subarray whose length is equal to k, that has whose length is equal to k, that has the maximum average value, and return this value. Okay, any answer with a calculation error less than 10 to the power of minus 5 will be accepted. This is the constant given, right? Now what you have to find it out? We have to find it out the contiguous subarray of this nums array. Okay, so what this nums array contains? It contains 1, 12, minus 5, minus 6, 50 and 3. And what is the value of k? K is given 4. So what is my subarray? You have to take a subarray of size 4. So what is my subarray? First subarray 1 is nothing but 1, 12, minus 5, minus 6. This is my first subarray. Okay, this is my first subarray. Okay, now in this subarray, what you have to find it out? You have to find it out the maximum average value. So for that, I will find it out the maximum sum first. Okay, maximum sum 1 is how much? It is 12 plus 1, 13. Okay, so 13 minus 11, it is 2. Right. Similarly, next check. What is the subarray 2? My subarray 2 will be, you have to slide the window by one step. So my subarray will be 12, minus 5, minus 6 and 50. Okay. So here what is the answer? 12 minus 11 is 1, 1 plus 50, 51. So what is my maximum sum? Maximum sum is 51. Okay. Now similarly, what is my third subarray? My third subarray will be from here to here. You have to slide it down. So my third subarray will be minus 5, minus 6, 50 and 3. Now let us find it out. What is the maximum sum? Okay, it is 53 minus 11. Right. So what is the value? 53 minus 11. So it is 42. So it is 42. Right. So out of these 3, what is the maximum sum? It is 2, it is 3. What is the maximum sum? Is 51. Now, you have to find it out the average, maximum average value. So, maximum average, how will you find it out? The maximum average is nothing but the maximum sum divided by k. Okay, what is my maximum sum? Is 51 divided by 4. It will be around 12.75. Okay, so this is the answer that we have got. So here we have to make the subarray of size 4 of size k. Then you have to find it out the maximum sum divided by the total number of values in that is 4. So divided by k value. So maximum average formula is maximum sum divided by k. So For each subarray, we have to calculate the maximum sum. So we got the maximum sum is 51. 51 divided by k is nothing but 12.75. Similar way, if there is only one value and k is equal to 1, so it is 5 by 1. So it is nothing but 5.00. But that is 5 only. Okay. So this is the question. Now, how to solve this question? Hope this question is understood. Now, how to write down the code in Python. Now, let us check. The first problem will take 1, 12, minus 5, minus 6, 50 and 3. So, what is my nums array? 1, 12, minus 5, minus 6, 50 and 3. Right? And k value is equal to 4. Right? And answer should be in float. Okay, fine. Now, find it out the length of nums array. So, it is 6. So, find it out the sum. Sum is nothing but sum of nums of k. So, starting index is not given. So, it is from 0 to k value is 4. So, 0 to 3. So, 0, 1, 2, 3, 4, 5. So, 0 to 3. 0 to 3 is nothing but this is the substring. Sorry, subarray. Okay. So, what is the sum of this? It is 2. Now, we'll take a variable called answer. Answer is equal to s, which is nothing but initially 2. Right? Now, for the remaining subarrays, we have to find it out the sum and you have to update. Now, for I in the range of k to n, what is the value of k? K is equal to 4 and n value is 6. So, I will take the values 4 and 5. Right? 2 more, we have to find it out. Right? So, what is the sum? Sum is equal to nums of I. So, sum plus means 2 plus nums of I, nums of 4. So, this sum already we know and just fourth one we have to add. So, it is 2 plus 50. It is 50. Right? Now, the first value you have to subtract. So, S is equal to S minus S is 52 minus nums of I minus k. I is nothing but 4 minus 4 is 0. So, this one you have to subtract, this one you have to add. Okay. So, it is 52 minus 1 is 51. Right. Now, what is your answer? Answer is equal to max of, earlier answer was 2, new answer is 51. What is the maximum? It is again 51. Right. Second time, I value is equal to 5. Again find out the S. S is equal to, so S is equal to S plus, what is the value of S is 51 plus nums of I. I is nothing but 5. So what is nums of 5? It is 3. So it is 51 plus 3 is 54. Again, we have to remove this value 12, we have to remove from here. Okay. So my second subarray is this one. Okay. So what we will do? S minus 54 minus 12 we have to do. Okay. So it is 42. Okay. Right. What is my answer? New answer is maximum of, answer earlier answer is 51. Common new answer is 42. So maximum of these two is 51. So the for loop has run 2 times. Third time this loop is going to stop. Right. Now finally what you have to return? Return you have to return answer by k. So answer is 51 divided by k value 4. So it is called float division. This is float division in Python. So which will give you 12.750000. So this is the answer. I hope this question is understood to everyone. So this is the way sliding window approach should be used for this problem. Next question will go for repeated DNA sequences. What is a DNA sequence? First, let us understand. The DNA sequence is composed of series of nucleotides abbreviated as A, C, G and T. For example, A, C, G, A, T, T, C, C, G is a DNA. It is a valid DNA sequence because it is composed of these 4 terms. Okay, 4 characters. Now, when studying DNA, it is useful to identify repeated DNA sequences within the DNA. Right? given a string S that represents a DNA sequence. So this is a string S which represents a DNA sequence. Return all the 10-letter long sequences, 10-letter long substrings that occur more than once in a DNA molecule. You may return the answer in any order. So more than once, if it is appearing also, we have to return, but it should be of length 10. So our K value is given as 10. This is nothing but our window size. In sliding window, this is nothing but our window size. And what is our input? Input is a string. Input is a string S. So if S and K are given, window size is given, then this particular problem requires a sliding window approach. Let us understand the test case. So here S is a very long string and your window size of 10 you have to find it out. So it is 5, 6, 7, 8, 9, 10. So up to this is a substring. Okay, this is a substring. So this substring will be there in our answer. Now if you will take K size of 10 for the next one. Okay, if the question is to find it out the anagram, then it will be anagram again. Okay, so next we will find out the next substring. This process will continue until you will get the next sequence. Okay, so our next sequence will be CCE 5 times A. This is from here to here. Okay, this process will continue and the same repeated subsequences are there, but we have to write only once. Now, let us see how to solve this problem using Python. Now, let me take any one substring. This is 13 times A is there. S is 13 times A is there. Okay. So, we have to find it out. 10 long sequence. So, 10 long sequence we will find it out up to this. Okay. Right. So, what you will do? So, input is a string and output is a list of strings. Output is a list of strings. We have to write it down. Right. So, we will first take a set called scene. If you will convert this into a set, then what will happen? Okay. What will happen? It will contain only the unique character A. Now, result is also a set. So, anyway, it is an empty set. Scene is an empty set and result is also an empty set. So, for I in the range of length of string is how much? It is 13. Okay. 6, 7, 8, 9, 10, 11, 12. So, it is 13. So, 13 minus 9. Okay. 13 minus 9 is 4. So, I will range from 0, 1, 2, 3, 4 times. Okay. Right. So, we will get the substring. So, what is my first substring? Substring is from 0 to 10. This is my first substring. 0 to your 9. Up to 9, this is my first substring. Okay. Now, if the substring is there in the scene, is it there in the scene? No, initial scene is empty. Then you add it to result. So, add it to result means what will happen? This substring of length 10 will be added 7, 8, 9, 10. This will be added to result. Okay. Now, then add it to scene also. So, what we will do? We will add it to scene also. So, this substring will be added to scene also. Right? Next. Now, second time I is equal to 1. So, it will be from S is equal to S of 1 to 11. So, it will be slided over by 1. Okay. It will be 1 to 11. The substring is there in scene? Yes, it is there. Okay. Okay. First time it is not there in scene, so you should not add it. Second time it is there in scene, yes, then you have to add it. Okay. Second time we will add it to result. Right? Okay. What will happen next time? S of 2 to 12. So, the third one, 2 to 12. Is it there in scene? Yes, it is there. Then add it to the result, add it to the substring. Okay, repeated, it is there. Then similarly, S of 3 to 13, it will do. So it is a repeated sequence, it is there in the scene. Okay, yes, it is there in the scene, then you have to add it to the result. And finally, we have to return the list of result. So it is a list of result, we will convert it into a list. So it will be a list. I hope it is clear. Okay. So in this video, we have learned what is sliding window approach, and we have learned how to execute the sliding window problems. So we discussed 3 problems today. One is finding anagrams and finding the DNA sequences. Okay. So this way, how to solve it, the anagram problems or DNA sequences using the sliding window approach, we have learned today. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.